We live in an era where um, literally everything in construction can be hyper-engineered. I mean, we are talking about an industry that is actively 3D printing entire houses
Uh,
from the ground up right now.
oh, yeah, absolutely. It's wild to see.
Right, and we have access to these highly manufactured, lab-tested, chemically perfected building materials, things like ceramics, sintered stones, advanced composites, and they're designed to perform exactly the same way every single time without fail.
They are incredibly predictable, yeah.
So with all of that at our fingertips, it begs a really provocative question. Why are the world's top architects, the biggest commercial developers and, the most cutting-edge designers, still completely obsessed with digging up millions of years old rocks?
It is a brilliant paradox, honestly. We possess this unprecedented technological control over our built environment, right? Yet, when a project demands true permanence or premium status, we bypass the laboratory and head straight back to the quarry.
We anchor our most modern structures with the Earth's oldest materials.
Exactly. We really do.
And that tension is what we are diving into today. We are pulling from a massive stack of sources today: industry white papers, architectural material guidelines, global supply chain reports, to truly understand the enduring relevance of natural stone in modern architecture.
Because it's not as simple as just picking a rock you like.
No, definitely not. We're going to examine the rigorous, highly technical criteria that professionals use to evaluate it. And we're going to expose the hidden logistical nightmares of global sourcing that, frankly, rarely make it into the glossy architectural magazines.
Yeah, because turning a rough geological formation into a polished commercial facade is, well, it's a staggering feat of engineering and logistics. The friction involved in moving literal mountains across oceans is immense.
It is massive, and this is essential intelligence for you listening right now. Whether you are an architect detailing a complex exterior, a commercial builder managing a ruthless project timeline, or an international buyer trying to source premium materials without getting swallowed whole by supply chain chaos, this deep dive is tailored for you.
Because the industry is shifting fast.
It really is. We are mapping out how this ancient trade is being forced to adapt to the speed of modern construction.
But, to understand the logistics, we first have to establish a motivation. We have to look at why developers and designers willingly take on the inherent risks and heavy logistics of natural stone when, like you said, synthetic alternatives are cheaper and infinitely more accessible.
Okay, let's unpack this contrast between natural and manufactured surfaces. 'Cause looking at the research, natural stone is resting on a few unshakable pillars.
Right.
The sources highlight its extreme compressive strength, its thermal mass, its completely unique aesthetic appearance, and its ability to ground contemporary, sometimes sterile designs back into the natural world.
And that aesthetic uniqueness is driven by something manufactured materials simply cannot replicate, which is geological time.
Right, time.
I mean, a factory can print a high-resolution image of a vein onto a porcelain slab in about 10 seconds, but it will always be a static image.
Using a synthetic stone is kind of like baking a cake from a highly calibrated, mass-produced mix. It is wonderfully predictable, homogeneous, and you know exactly what you're going to get.
Exactly.
But natural stone, on the other hand, is like foraging for truffles or producing a vintage wine. The specific soil chemistry, the local climate, the tectonic pressure, and the mineral runoff over millions of years dictates its exact density, porosity, and color.
It's so specific to the region.
Yeah. You're just buying a surface look. You're buying a specific slice of a specific mountain.
That is the perfect way to frame it, the terroir of the stone, if you will.
Ooh, the terroir. I like that.
A manufactured slab lacks that geological fingerprint. In natural stone, the variations in mineral patterns and slight shifts in texture reflect the actual chaotic forces of the earth.
But wait, breathing life into a building with a geological fingerprint is great for an architect's portfolio, but what about the builder? Let's look at this from a risk management perspective.
Sure, yeah.
If I am a developer installing a 50-story commercial facade and slab number 400 has a completely different mineral density, vein direction, or color tone than slab 401, that architectural identity just became a massive, costly delay. How do top-tier firms justify that unpredictability?
Well, it comes down to how they manage tolerances. The variation isn't a surprise to experienced professionals. It is factored into the fundamental design and engineering phases.
Oh, so they plan for it from day one.
Absolutely. Top firms utilize advanced building information modeling, or BIM, and dry laying processes. They map out the exact slabs digitally before a single piece is shipped to the site.
That is wild. They map every slab.
Every single one. They aren't hoping for uniformity. They are actively designing a cohesive installation out of natural variance.
Right.
When managed correctly, that unpredictability isn't a delay. It's the very feature that elevates the space from simply being constructed to being a landmark.
Which means knowing exactly what you were specifying is paramount. You can't just write stone on a blueprint and hope for the best.
No, you really can't.
The sources break down the architectural landscape into 7 primary categories. So we have marble, granite, sandstone, limestone, quartzite, slate, and travertine. But structurally, these can't all serve the same purpose, right?
Not at all. Their functional applications are entirely dictated by how they were formed in the earth. You have to look at whether they are igneous, metamorphic, or sedimentary rocks.
Let's start with the heavy hitter, which is granite. The research notes this is the go-to material where extreme durability and abrasion resistance are absolutely critical. We're talking high-traffic commercial floors, exterior paving, demanding facades. Why is it so much tougher than the others?
So granite is an igneous rock. It is formed from magma slowly cooling deep beneath the Earth's crust.
Okay.
And because it cools so slowly over millions of years, it grows large, tightly interlocking crystals of quartz and feldspar.
And that makes it stronger.
Yeah, that crystalline structure gives it immense compressive strength and makes it incredibly dense. It doesn't scratch easily, it handles heavy point loads, and it is highly resistant to chemical weathering. It is basically the absolute workhorse of the industry.
Then, on the other end of the structural spectrum, you have marble, which the sources highlight as the ultimate symbol of luxury. It's utilized heavily in high-end interiors, lobby walls, intricate architectural detailing.
Right, and marble's behavior is tied to its metamorphic origins. Marble actually starts its life as limestone, which is a relatively soft sedimentary rock.
I didn't know that.
Yeah, but when that limestone is subjected to intense tectonic heat and pressure deep underground, the minerals recrystallize into a denser calcite structure.
But it's still softer than granite.
Considerably softer, yeah. The calcite structure gives marble that famous, slightly translucent, luminous quality that allows light to penetrate the surface before scattering, which is why sculptors and architects love it.
It's beautiful.
It is, but that same chemical composition makes it vulnerable to scratching and, more importantly, vulnerable to acids.
Which brings up a massive pitfall in the industry. I see that all the time when inexperienced buyers prioritize aesthetics over physics.
Oh, definitely.
If you just specify a gorgeous porous limestone or a delicate marble for a commercial exterior without evaluating the local climate, you are asking for a structural failure.
It's a disaster waiting to happen.
Right. Imagine putting a highly porous sedimentary stone on a facade in a city with a harsh freeze-thaw cycle. Water infiltrates the stone's capillaries during the day, freezes at night, expands by about 9%, and literally pops the facade off its mechanical anchors.
Yep.
It's not just an aesthetic mistake. It is a multi-million-dollar liability.
What's fascinating here is that you've just highlighted the exact mechanism of failure capillary action and thermal expansion. And that is why the selection criteria used by professional architects is so exhaustively rigorous. The visual appearance is honestly just the final 10% of the decision.
So what makes up the other 90%?
The technical checklist. Before a stone is ever approved, engineers must evaluate its water absorption rate to prevent the exact freeze-thaw disaster you just described.
Wow, okay.
Yeah, they have to test its flexural strength to ensure it can withstand wind loads on a high-rise. They calculate the slip resistance of the specific finish applied to the stone for commercial flooring. They dictate the exact thickness required for the anchor systems, and they have to map out the long-term chemical maintenance requirements.
And we haven't even touched on quartzite, which the research points out is becoming incredibly popular for premium applications.
Quartzite is the perfect example of geology meeting modern demand. It is a metamorphic rock that actually originates as sandstone.
Interesting.
But through extreme heat and pressure, the sand grains and silica cement fuse together into an incredibly dense network of quartz crystals.
So it looked a bit like marble with those elegant sweeping veins, but it performs
much closer to granite, exactly that. It offers a premium, luxurious aesthetic, but boasts a hardness that can withstand demanding commercial environments. But because it is so incredibly hard, it is notoriously difficult and expensive to quarry and fabricate.
I can imagine.
Yeah, it burns through diamond cutting tools much faster than marble, which inherently drives up the project budget.
And we also have slate and travertine rounding out the Magnificent Seven. Slate, with its unique cleavage planes making it perfect for roofing and cladding, and travertine, formed in hot springs, known for its distinct natural voids.
Right, and each of these 7 categories is a highly specific engineered asset. You are drafting a geological formation to perform a job in a human environment.
Okay, let's say the architect has run that rigorous gauntlet. They've evaluated the local freeze-thaw cycle, they've factored in the wind loads, they've modeled the exact flexural strengths required, and they have selected the absolute perfect quartzite for their project. Now comes what the sources indicate is arguably the most brutal phase of the entire process: procurement. Getting that specific stone out of a mountain in one hemisphere and safely onto a job site in another.
The logistics of international stone sourcing, it is a fragmented, incredibly complex undertaking.
Here's where it gets really interesting, because the sheer logistical friction of this industry is hard to overstate. It's not like sitting in an office in London or New York and clicking add to cart for a steel beam or a pallet of acoustic tiles.
No, not at all.
Sourcing for international projects involves moving literal tons of earth across the globe. How does a buyer even begin to guarantee quality and exact specifications from 4,000 miles away?
It is historically one of the most opaque supply chains in modern construction. You have to remember, a quarry isn't a factory.
Right.
You can't just ramp up production if you need more of a specific color. Let's trace the reality of a large commercial order. Let's say an architect specifies a distinct white marble with bold gray veining from a quarry in Europe.
Okay, I'm with you.
First, the quarry has to locate that specific vein within the mountain. They use massive diamond wire saws to slice a 30-ton rectangular block out of the bedrock.
30 tons, that's massive.
Huge. But nature is chaotic. What happens if a tectonic shift 1,000,000 years ago created a microscopic fissure running right through the center of that block?
You wouldn't know until you cut into it, right?
Correct. The block is sold to a regional processor, loaded onto a specialized heavy-haul truck, and driven down a mountain to a facility where a gang saw slices it into slabs. Only then, after weeks of work and thousands of dollars in transport, do they see the fissure.
Oh, man.
Yeah, the yield of usable architectural slabs just plummeted by 40%.
And if you're the builder waiting on the other side of the world, your project timeline just took a massive hit. You were suddenly 6 months behind schedule because of a hidden crack in a rock.
And this raises the core issue highlighted in the research. The natural stone industry is an intricate, deeply interconnected web of geology, manufacturing, heavy logistics, and international trade.
It's so much more than just digging up a rock.
Way more. Because of these inherent risks, the variations in yield, the microfissures, the unpredictable veining, the industry historically relied on a massive buffer of middlemen.
The traditional supply chain. So you have the quarry owner, the local agent, the regional processor, the export broker, the shipping firm, the import broker, and finally the local distributor. Every single one of those layers adds a markup to the price.
They add cost, yes, but more detrimentally, they add information asymmetry. It becomes a global game of telephone.
Yeah, that makes
The
sense.
fabricator cutting the stone in one country rarely has a clear line of communication with the architect designing the building in another. So verifying exact specifications, requesting specific geological test reports, or simply confirming that the material is actually available becomes a monumental task.
Which means evaluating quality from afar isn't just difficult through that many layers of brokers. It is virtually impossible to do with total confidence. The friction is simply too high for the pace of modern, globalized construction.
The industry was facing a bottleneck. The demand for premium natural materials in commercial and high-end residential development has never been higher, but the archaic, fragmented procurement process was suffocating the market.
So to survive, the business-to-business market had to evolve. It had to find a way to collapse the distance between the quarry face and the construction site. And the sources point to a structural shift happening right now, with digital platforms stepping in to solve this exact bottleneck.
Yes, the digitization of the stone supply chain. It's a game changer.
The research highlights Stone Mandi as a prime example of this evolution. It is a B2B natural stone marketplace designed specifically to circumvent those historic supply chain hurdles. Its primary function is quite simple on paper, really. It connects genuine project buyers directly with verified natural stone suppliers.
That word directly is the entire fulcrum of this shift.
Right. It covers all the major categories we decoded earlier: marble, granite, quartzite, slate, and the rest. But it explicitly operates without brokerage or commission. It essentially centralizes that massive, opaque web of international trade into a single digital infrastructure.
Exactly.
So what does this all mean? I want to make sure we approach this critically because it's easy to say a digital platform streamlines things. But I have to push back here.
Go for it.
We just established that the biggest risks are highly physical, technical variables. Evaluating a 30-ton block for hidden fissures, matching exact vein directions, confirming water absorption rates. Does simply cutting out a broker and jumping on a B2B marketplace actually solve those boots-on-the-ground technical headaches?
If we connect this to the bigger picture, we can see exactly how transparency acts as a risk mitigation tool. The opacity of the traditional supply chain was actually the primary barrier to quality control.
How so?
Well, when you remove the 3 layers of brokers, you aren't just saving on commissions, you are opening a direct line of communication.
How does that play out in practice, though?
Let's go back to our architect in New York and the quarry in Europe. Through a verified platform like Stone Mandi, the buyer isn't relying on a broker's vague assurance that the stone looks good.
Right.
They can communicate directly with the supplier. They can request high-resolution video verification of the exact blocks being pulled from the mountain. They can review the geological lab test reports directly from the source to confirm the exact compressive strength and porosity.
Oh, that's huge.
It is. They can even share their digital BIM templates so the supplier knows exactly which vein alignments are required before the stone is ever loaded onto a container ship.
Ah, I see. By eliminating the telephone game, you eliminate the information asymmetry.
Exactly.
The buyer discovers suitable, highly specific materials with full technical transparency, and the verified suppliers reach genuine international projects without their margins being eaten alive by middlemen.
It clears the fog off the global scavenger hunt. It allows the professionals to focus their energy on engineering the material for the environment rather than fighting a convoluted supply chain. It takes an ancient trade and finally equips it with a modern infrastructure.
Which brings us full circle to why this matters so much. As we distill everything we've pulled from the research today, the core insight is undeniable. Natural stone remains a cornerstone of modern construction because it is far more than a simple building material. It is a vital piece of a project's architectural identity.
It provides unparalleled durability, thermal performance, and an aesthetic depth that synthetic manufactured materials simply cannot replicate.
Right.
Whether an architect requires the immovable strength of granite for a plaza or the luminous elegance of marble for a lobby, the geological reality of the material dictates the soul of the space.
And as the technical and logistical demands of global development continue to accelerate, the way we source these millions of years old rocks is finally catching up. B2B platforms like Stone Mandi are proving that you can modernize the ancient trade by directly connecting the globe's buyers with verified suppliers, stripping away the opaque layers of brokerage, and dramatically reducing the friction of international logistics.
It ensures that the industry can meet the demands of the future without losing its connection to the Earth's history.
Beautifully said. And as we wrap up this deep dive, I want to leave you with a final thought to ponder. We spent a lot of time today analyzing logistics, technical specifications, and supply chain efficiency. But step back from the blueprints and the spreadsheets for just a second.
Yeah, look at the big picture.
Every single natural stone slab tells a chaotic, beautiful geological story that was literally millions of years in the making. So when you factor that in, how does the specific stone that you select for your next project fundamentally change the legacy and the story of the building itself?
It's powerful stuff.
You aren't just designing for the next 50 years. You are incorporating the last 50 million.
That is the true weight of the material.
Something to think about before you sign off on your next material schedule. Thanks for diving deep with us.